On April 3, 1974, spring weather conditions across the central and eastern United States appeared consistent with seasonal patterns. Commercial air traffic maintained standard routes between major metropolitan areas. Interstate highway systems operated at normal capacity. Power distribution networks supplied electricity to millions of residential and commercial structures across 11 states. Local weather services monitored developing atmospheric systems using existing radar infrastructure and scheduled observation protocols. Tornado warnings in this region typically occurred individually, with emergency response systems designed to address isolated events affecting limited geographic areas. The affected zone extended from the Mississippi River Valley eastward through the Ohio River Valley and into the Appalachian Corridor. Population centers included Indianapolis, Cincinnati, Louisville, and Huntsville, with combined metropolitan populations exceeding 4 million. Interstate highways 65, 70, 71, and 75 formed primary transportation arteries. Electrical transmission systems operated through regional grids connecting thermal and hydroelectric generation facilities. Emergency services infrastructure consisted of county-level warning systems, municipal fire departments, and hospital networks designed for routine disaster response. Agricultural land dominated rural areas, with tornado shelter availability limited to basement structures in older construction. Mobile home concentrations existed in suburban and rural districts without reinforced protection options. A deep low-pressure system moved from the Central Plains into the Great Lakes region on April 3. Surface temperatures across the outbreak area reached 70 to 80 degrees Fahrenheit, with dew points exceeding 60 degrees. A strong southwesterly jet stream at 250 millibars produced wind speeds exceeding 150 knots over the Ohio Valley. Warm, moist air from the Gulf of Mexico surged northward ahead of an advancing cold front. Upper-level divergence and surface convergence created conditions for rapid vertical motion. The synoptic pattern generated atmospheric instability values between 2,000 and 4,000 joules per kilogram across multiple states simultaneously. Wind shear profiles indicated strong directional and speed variations through the troposphere, producing rotation potential in developing thunderstorms. By early afternoon, atmospheric soundings revealed extremely favorable tornado parameters across a 400-mile-wide corridor. Convective available potential energy, or CAPE values, reached extreme levels for the season. Bulk wind shear magnitudes exceeded 50 knots in the lowest 6 kilometers. Storm relative helicity values indicated high tornadic potential. Multiple supercell thunderstorms developed nearly simultaneously along and ahead of the cold front. Radar systems detected hook echoes and mesocyclone signatures in numerous storms across the region. The atmospheric environment sustained tornado production for extended periods without typical diurnal weakening. Supercell density reached levels unprecedented in observational records, with multiple violent-capable storms operating concurrently across state boundaries. The first confirmed tornadoes touched down in Illinois and Indiana shortly after 1 p.m. Central Time. Within 2 hours, violent tornadoes rated F4 and F5 on the Fujita scale were simultaneously on the ground in multiple states. The Xenia, Ohio tornado began at approximately 4:40 p.m. Eastern Time, producing F5 damage through the city center. The Brandenburg, Kentucky tornado tracked across populated areas concurrent with other violent tornadoes in Indiana and Alabama. Temporal spacing between tornado formations decreased to intervals measured in minutes rather than hours. By 6 p.m., emergency management systems faced simultaneous tornado warnings across regions covering more than 100,000 square miles. Between 3 p.m. and 11 p.m., 148 confirmed tornadoes occurred across 13 states. 30 tornadoes achieved F4 or F5 intensity. Multiple violent tornadoes maintained ground contact simultaneously in different states, creating overlapping emergency response demands. Alabama experienced devastating tornadoes, while Ohio, Indiana, and Kentucky faced concurrent violent events. Communication systems became saturated as multiple counties issued warnings simultaneously. Emergency dispatch centers received call volumes exceeding capacity. State emergency management agencies coordinated responses across multiple disaster zones without precedent for such geographic scope. Interstate mutual aid systems faced requests from multiple states simultaneously, fragmenting available resources. Power transmission infrastructure sustained damage across multiple states, creating cascading grid failures. The Xenia tornado destroyed electrical substations, leaving 27,000 residents without power. Transportation networks experienced simultaneous disruptions as tornadoes crossed interstate highways in multiple locations. The Brandenburg tornado severed river crossing capacity. Hospital systems in affected cities transitioned to emergency operations while receiving mass casualty influxes. Telephone switching stations sustained direct hits, eliminating communication capacity in affected zones. Water treatment and distribution systems failed where facilities sustained structural damage. Natural gas distribution networks required emergency shutdowns to prevent secondary hazards where infrastructure integrity was compromised. The National Weather Service issued over 100 tornado warnings during the outbreak period. Warning lead times averaged 11 minutes, consistent with existing radar and spotter network capabilities. Multiple simultaneous warnings created information processing challenges for emergency managers and public recipients. Siren systems in some communities activated repeatedly over several hours, creating ambiguity about immediate threat proximity. Radio and television broadcast systems attempted continuous coverage across multiple concurrent tornado events. Warning fatigue affected public response as alerts continued throughout the evening hours. Coordination between state emergency operations centers and county agencies faced delays due to communication system overload and the geographic distribution of simultaneous impacts requiring prioritization decisions. The outbreak resulted in 315 confirmed fatalities across the affected states. Over 5,000 individuals sustained injuries requiring medical treatment. Approximately 27,000 families experienced housing destruction or severe damage. The Xenia tornado alone caused 33 deaths and destroyed half the city's structures. Alabama tornadoes produced 77 fatalities across multiple communities. Brandenburg recorded 31 deaths from a single tornado. Infrastructure damage affected approximately 900,000 residents through direct structural impact or utility service loss. Emergency shelter requirements exceeded 10,000 persons in the immediate aftermath. Search and rescue operations continued for 72 hours following the outbreak across multiple disaster zones. Debris removal operations began April 4 across affected communities, with National Guard units deployed to 11 states. Power restoration required weeks in severely affected areas due to transmission infrastructure replacement needs. Interstate highway repairs prioritized major routes, with full restoration completed within 10 days. Water and sewage system repairs extended beyond 1 month in communities experiencing direct tornado impacts. Temporary housing solutions included FEMA trailer deployments and emergency shelters converted to medium-term facilities. Communication system restoration required rebuilding telephone exchanges and transmission towers in affected zones. Federal disaster declarations enabled coordinated resource allocation across state boundaries. The National Weather Service documented 148 confirmed tornadoes over the 16-hour period from April 3 to 4, 1974. 30 tornadoes received F4 ratings, and 7 received F5 ratings, representing the highest concentrations of violent tornadoes in a single outbreak in recorded U.S. history. Total tornado path length exceeded 2,500 miles. Property damage estimates reached $600 million in 1974 dollars. The outbreak prompted subsequent modifications to tornado warning systems, radar technology deployment priorities, and emergency management coordination protocols for multi-state disaster events. The event established baseline metrics for outbreak-scale tornado events in atmospheric science and emergency management literature.